The goal of this video is to take you from the very beginning of an opening of a Unity project to importing the assets that are required to use a motion capture system from SMALLab, and to have the fundamental setup that's required to get up and running with a new scenario. So first thing that I want to do is I want to create a new project, and I'm going to name this my SMALLab project. Okay. When this opens up, you'll see basically, apart from this camera that's provided by default, which I'm actually going to right click and then delete, we have a totally blank slate. The first thing that I want to do is to actually import the SMALLab package. So I'm going to import a custom package, and I have this on my desktop, and you'll see here the SMALLab assets package. And here's a listing of all the different components that are in that package. Yours may be a little bit different depending on when you've received it, but this is what mine looks like now. So I'm going to import that package, and when I do, we should see here that we'll get the basic assets that are required in order to do the setup. So we have a few prefabs in the calibration setup, we have a camera, we have the I/O, which is where we'll have the motion capture data coming in from, and then we have some basic prefab objects that I can use in order to get up and running, just to make sure that I have the essential setup going. So first thing that I want to do is I want to bring a camera into the space, and I'm going to take the SMALLab camera. This is particular to the setup because you'll notice as I back up and highlight the camera that the camera is actually arrayed above the space, and then it's actually looking down. So in this setup we have the camera essentially in the spot where the projector is in the large space, in the physical space. Okay, so next thing that I want to do is I actually have my OptiTrack system running, but I want to now be able to read that data into my Unity project. So I'm going to take the OptiTrack prefab and drag that into the scene. In the same way, I'm going to take the trackables in. So the OptiTrack system is actually what reads the motion capture stream, and the trackables is the object where the various tracked objects are stored and then broadcasting to the other elements in your scene. So you'll notice that none of these actually have a rendering component. These are just the fundamentals that are required in order to process the input data itself. Okay. Now that we've done that, I want to bring in another object, and this will be one that I can use for debugging to make sure that I'm getting data coming into the system. It's called 3-axis rotation. And if I zoom in here, you'll be able to see that this has the 3 axes that are required: blue for Z, green for Y, blue for Y, green for Z, and a red for X. Okay, now I actually have my OptiTrack system running already, so if I press play, we're going to see that when this starts, the object actually moves. That's because I'm actually reading in the data from the OptiTrack system, both the position and the orientation of that data. So you see it moving in this scene, and you also see it moving down here in the actual game view itself. So that's good. That means that I'm actually getting data coming in, and then I'm able to move that object around. So let's look quickly at the 3-axis rotation object to understand how that's happening. So this is the basic model that you use to set up your objects in this space. So you'll notice that I have an ID for the object itself. This is going to match the ID that you set for a given object in the OptiTrack system. And then you also have a script. So let's look at that script real quick. So in here, you'll see that I have that variable which defines the ID of the object itself. Start and update don't actually do anything. The important things that are required in order to be able to read that data is to handle tracked object data, which is going to send me an array of tracked objects. Now, in this case, what I do is I go through that array of objects, and I look to see if the particular ID matches this ID that I have, and if it does, then I want to take the position of that tracked object and assign it to the position of this rendered object, and do the same with the rotation. Okay, the other thing that we'll look at in just a moment is this handle physical dimension, but this is the key element to be able to move from the motion capture data and then assigning that to any object that you're going to put into this space. Okay, now there's something it's critical to understand about the setup of SMALLab, which is that we need to make sure that there's an alignment between the physical space and the virtual space. So, you may have a SMALLab setup that is 3 meters wide by 3.5 meters tall. You may have it 3.5 meters, you may have it 2.5 meters. It could be any variety of basic dimensions, and we need to make sure that that data from the physical tracked objects coming into OptiTrack and then into the Unity platform is aligned. Okay, so the way that happens is that there's actually, when SMALLab starts, it will read a set of dimensions that are set essentially as a preference, and then it will broadcast that so that you can update objects so that they're in the right position and size. The scale is appropriate to the dimension itself. Okay, to help you in that process, what I've done is there's actually the space dimensions object, which doesn't have a rendering component. What this does is just receives those dimensions, the x, y, and z dimensions of the physical space. And then what I've done as well is to include an interactive space guide which will show you that size. Okay, so this is the thing that you can use in order to make sure that you're putting things in the correct dimension into the scene that you have. So you'll notice that this interactive space guide includes a cube, and then it has an origin in the same as the others. So this is at 0, 0, 0, and then you just have poles that delineate each corner of the space itself. All right, notice what happens when I press play. So you see that suddenly the size of this space gets larger. Now the important thing here is that when it's in its default mode, the space guide is scale 1, 1, 1. When I press play, Apple P on a Mac, you'll see that this moves to 3.5, 2.5 by 3.5. These are the dimensions, the physical dimensions of my physical SMALLab setup that then are aligned here. And so the important thing is that they boost up in size. The other thing you'll see is that the position of this object not only takes the position of the trackable, but it also moves in accordance to the dimension of the new space itself. So this is critical that you include these elements, and the way that you include them is again in this object rotation that's provided as a sample. I handle the physical dimensions. So I will have coming into my script a dimension, a three-dimensional vector. And what I do here is I take that dimension and I multiply it by the scale of my object. So you may have different ways you need to use that. You may also need to update the position of your object depending on that, if it's, for example, a fixed object and not just tied to the trackable itself. So that's a critical piece to understand as you build out your scene. And again, when I have this space guide included as a guide to help with debugging, but you can of course always turn this off so that it's no longer visible. And so now, when I play this scene, I no longer see that other space guide. All right, that's it.